.com Cisco document for SD-WAN.
Yeah, it is visible.
Okay. So the very first question, even for me, whenever I hear about anything new, why we really need that, right? Why SD-WAN? Why not something else, right? What were the key reasons why SD-WAN was invented? Who invented this, right? Who is managing this? Because there are many players in the market nowadays who are running SD-WAN, right? Technology. So now I'm switching over to my main screen. I hope it is visible for everyone. So we have Cisco SD-WAN, Meraki, also a Cisco SD-WAN flavor, right? Then Fortinet SD-WAN, right? Velo Cloud, Versa. Then there is Palo Alto, Nokia Noise, Silver Peak. There is Kato as well. We have Arista. So many SD-WAN vendors, right? They all have their own proprietary ways of working. No SD-WAN service technology framework is compatible currently. The compatibility between different vendors. Like if we have a Cisco router, if I have, let's say, Juniper Make router, HP, Alcatel Lucent router, let's say, I'll type down the names. So if we have four different vendors, if they are having point-to-point links, connections, back-to-back cables, let's say, some sort of connection between them, if we want to run a ping command, it will work, right? The syntax may be different when we are pinging the IP addresses of different routers. On, let's say, on Juniper platform, the command may be, let's say, run ping. On Cisco routers, the command would be, let's say, ping. On HP, Alcatel-Lucent, different vendors, the command may be different. We can run BGP, we can run OSPF across different platform, diverse platforms, and it is fine, right? They work as expected normally. However, in terms of SD-WAN, no vendor is such diverse or compatible. S- Cisco Catalyst SD-WAN, all the devices should be part of Cisco SD-WAN. A device as Cisco SD-WAN cannot communicate with, let's say, Meraki or Fortinet in terms of SD-WAN. However, IP reachability would still be there, but SD-WAN will not work. So I'll explain what is the difference, right? Why it does not work, how it is different from the normal routing, right? Now, before I move on further, I want to first share with you the ultimate goal, why we really need network, why we really need, let's say, SD-WAN. Oh, sorry. So why we need SD-WAN? Let's maybe move to different screen. Why we need networks? Before we talk about SD-WAN, let's talk about networks. Any idea, anyone who want to share? Why we need networks? So one of the reason, as we are connected to this meeting, we are using network in some manner. This meeting which we are connected, which we are part of, is based out of internet only, right? So the network communication may be private or it may be public. So if let's say if it is me, if it is let's say Azim, so we may be connected to different internet providers. Somebody would be connected to let's say Airtel network. Someone else may be let's say connected to level 3 internet network, right? Somebody else may be connected to some other provider. Whosoever, let's say if we are connected to this meeting, then what internet is? Collection of different ISPs. This is what public internet is. The connection between, they have connections between them. They are called ISP peering. It may not be full mesh. It really depends how they are connected. But in some way, for any ISP to be present on the internet, they must be connected to other providers. So this is how public internet works. This is, let's say, me sitting here, right? Then this may be, let's say, Azim, home, let's say, broadband router, or if they are sitting in some office, some, let's say, public places. So some router would be there through which we all would be having internet, and then we are sitting behind using our laptops, tabs, mobiles, etc., and then connected to this meeting. It may be wireless, it may be wireline connection. This is one of the goal of the network, why we need network. And this is the example of public internet. Now, let's talk about the private network. That was public network, and let's talk about private network. We can think of, let's say, some offices, their routers, right? Usually, this private network may be the connections connected onto one provider only. It may be, let's say, Airtel MPLS. These are three circles representing the routers. This may be Delhi office or let's say any XYZ company, let's say LIC India, their Delhi office, their Mumbai office for LIC, and this may be, let's say, their office in US. Now, they would have their routers which are connected to the Airtel MPLS, so they must have subscribed to the MPLS lines, and then there would be users sitting in the office, maybe again laptops, desktops, printers, servers, wireless users, right? Let's say tab, and this would be the flow for them. This is how Delhi office users would be communicating to the Mumbai office users. Could you please mute in case you are not speaking into this meeting? Yeah, thanks. So this is the example of private network. So SD-WAN can be established for both private public networks or for the combination of both. There may be a scenario, right? Even if, let's say, if I cut it out, if it's not only a private network, I may, let's say, call it hybrid network, combination of both public and private. How that would be? So I would need connection to the internet as well. Let's say my Delhi and US office, they may be connected via one provider or different providers, or we can say this is example of the internet network or public internet. This is private network, that is internet public network. So Delhi office would be having internet line via maybe XYZ provider, and US office would also be expected to have internet line in case they want to communicate, right? Then this is the ultimate goal. This line would be usually the internet based lines, they are the backup lines, backing up the primary MPLS connection. So internet lines, they are cheaper, and MPLS lines, they are expensive. So why SD-WAN now? The question comes here. In the early days, let's say 10, 15 years back, the internet performance was not so good. The internet network, there were high latencies, packet losses, degradations, several issues were there. But over the period of time, internet is stabilized, it has improved. So to save cost, which is the ultimate goal, to save cost, organizations started using internet lines. We can still use internet line without moving to SD-WAN, but with internet lines, there is problem of security. They are not secure because they are open lines and there is no private network. It's all public network and with no responsibility of any provider. They are just giving us communication medium to communicate. They are not responsible for the security. So anybody who is sitting on internet can sniff what communication is ongoing. However, via private lines, it is secure because it is part of one provider only and they are responsible to provide security to ensure that data is not hacked, right? There is no security worries about private network. That is why name also signifies private. Internet, it is called as public network. It's open network. It since it is combination connection of different providers. So nobody has real responsibility across whole path. Let's say if myself and Azim, we are sitting across different providers, right? So this is where nobody owns the responsibility. Somebody sitting here can try to sniff into what communication is ongoing. But with private network, there is no such problem. They are secure. They are part of one provider only. Anything so far? Any question? Okay, assuming nothing. Okay, so to save cost, a network, a technology was designed to counter the to counter the network with security. So with
One
SD-WAN, what?
question.
Yes, yes,
One
please.
question, sir. Sir, if you change to the like SD-WAN, suppose
Mm-hmm,
if you require like we have the purchase for the public IP. Right now,
mm-hmm,
if you go for the MPLS link, we don't need to the purchase for the any public IP. There's a
correct,
static normal IP is there. When
correct.
you shift it to the SD-WAN, we purchase for the public IP. Am I right?
Yes, yes. But again, that is way less cheaper than MPLS.
Okay, yeah. That is okay, yeah.
So if we, let's say again, look at the similar network, three offices. One, we talked about, let's say Delhi, LIC office, right? Mumbai, and then US. I'm assuming they are connected via internet lines only. Since we are talking about internet, so let's say they are connected to different providers altogether. So different offices connected to different providers. So these are, I'm representing as if they are different providers. Airtel level 3, let's say code. Now here up till this point is the responsibility of Airtel to provide us security, good performance, internet line, everything. They are responsible for this. This is in the ISP terms, this thing, this area, this line is usually called local loop. This black line, this is representing a router, this is representing the ISP side, and this black line, this is representing a connection. It may be fiber, it may be copper, or it may be a wireless line, right? So this is the Airtel's responsibility area. However, the problem is here. Nobody owns this area. However, although this cable is between Airtel to level 3, this line, they both would be taking care of mutually. There may be some commercial agreements that who will take care of what part, right? But in terms of security, in terms of data security, nobody owns this thing. It's open. So everybody is aware, they are well informed that this is open area and nobody owns the security responsibility. So anybody who is using this path should secure their data by themselves. How? That would be secured by setting up IPsec tunnels. So Delhi LIC office and Mumbai LIC office, they would be setting up logical virtual IPsec tunnel, which would be following physically this path, but virtually it would be direct between them. Physical path would be this one, but we would be representing this as the virtual logical IPsec tunnel. If you haven't worked on IPsec tunnel, don't worry. I'll be talking about IPsec tunnel as well as the prerequisite. So it's a logical path that is established between Delhi to Mumbai office, and usually this is manual thing that we need to do on both sides. If you want to extend secure path across Delhi to, let's say, US office, we need to set up another tunnel. If you want to have similar path between Mumbai to US, we need to set up another tunnel. This was the real challenge when we started using internet lines only. To save money, we started using internet lines. However, there was problem of security. That problem of security is covered by configuring these manual IPsec tunnels. But again, it's overhead of configuring the tunnels on each and every router. Let's say if I'm going to add a new office in US itself, let's say, if I want to set up now IPsec tunnel, I would need to because of the security reasons. Now I would need to configure 3 tunnels on this router as well as one on each of the other routers. So as the number of offices increase, so the complexity would also increase. Now you will see the beauty, the advantage that we have with SD-WAN. So with SD-WAN, what happens? We have our offices connected via some providers. This is the responsibility of the internet providers to give us connectivity. They are already there. So the connection between them would already be there. So in some manner, these 4 circles routers would be connected via, let's say, 4 different ISPs, 4 different providers. who are providing the internet connectivity. Instead of having these manual IPsec tunnels, there would be automatic IPsec tunnels between all the devices. Logical IPsec tunnels. So automatic logical IPsec tunnels. This is possible with SD-WAN only. We don't need to do anything manual. It's all automatic. As soon we add a new router into our network, as soon this has the connection to the network, this router would automatically set up logical IPsec tunnel to other all routers, be it 10 routers, be it 10,000 routers. Anything on this? You
Hello.
have the idea? Yes, yes, please.
Yeah, so I just want to ask you in this. So
Uh-huh.
whenever we creating that automatic logic IPsec tunnel,
Hmm.
so it's required any any data center or it is directly connected to all the branches.
So,
It's suppose
irrespective of,
example, like
uh-huh,
suppose example, I have
uh-huh,
a one branch in Mumbai.
okay,
So and there is another branch in the Delhi.
okay,
And the multiple state is there. So I have multiple branches. So suppose that I am
mm-hmm,
creating the IPsec tunnel in between of the all the
mm-hmm,
branches.
mm-hmm.
So it would be like connecting directly, or it is passing from one of my DC, then it is going there.
So, default behavior is the direct IPsec tunnel. However, if we want, we can let them pass through one specific data center as well. It's up to us. We have that much flexibility.
Okay.
Yeah. Okay. Does that answers your question?
Yeah, yeah. Thanks.
Okay.
Thanks.
Okay. Yeah. Yeah. Great. Great. I really like this. Right. So when you are asking questions, right, then I am confident that we are in sync, right? But I am sharing that you are understanding it. If you are into something new, right, there would be questions in your mind, right? Don't think that the question may be as silly as it is, right? But when somebody is learning, so it's not silly, right? It's logical because you are trying to learn something. So of course there are expected questions, so please feel free to raise in case you have anything, right? Okay.
And one more
Yes,
question
please.
also.
Mm-hmm.
Suppose that you explain the MPLS connectivity,
Mm-hmm.
which is I understood properly. But
Mm-hmm.
in the manner we are saying like this is our private network. Suppose we have a
Mm-hmm.
multiple states who are connecting with the
Mm-hmm.
MPLS network
Mm-hmm. Mm-hmm.
uh, as a like a private network. We are saying as a private network. In the
Yes.
whole and cell, we are looking our traffic is going in the ISP end. Okay.
Mm-hmm.
From the
Mm-hmm.
ISP, it is going to my another state office
Yes.
via the MPLS connectivity.
Yes, correct.
But in terms of we are saying it is private, but whole
Mm-hmm.
and solely our traffic is going to the ISP end. So it
Okay.
would be any sniffer or we are giving any BGP connectivity in between of them.
Okay, yeah, I understand your question. So it's very much logical that it is, although we are saying it is a private, right, but it is not private. This is what your question is, right? Because it is traversing via one provider, right?
Yeah, that is my question. Like we are saying as a private network and
Yes,
but it is however we are saying the traffic is going to the internet, then it is going to my another office with the help of the ISP link.
absolutely
Like
right.
who is responsible? The ISP of that my
Yes,
link and the data.
you are absolutely right that even though we say this is private, this is not totally private. This is a shared network because there would be different clients who would be using Airtel MPLS, right? But why we say private? Because it is one entity only. If our data is hampered, if our data is manipulated, right, if it is corrupted or something happens, we have only one entity to blame. There is nobody else in between. Either me, my Delhi office router, or it is the Airtel router, maybe in Delhi, maybe in US, and then my device. These lines, they are solely owned, protected by Airtel. So it is their responsibility. That is why we call it a private network. However, it is not 100% you can say private. The reason again, because we are using ultimately the provider of the Airtel network, right? What the alternate connectivity solution is having point to point links between the locations. Without using Airtel as provider, I can have point to point links. Fiber, right? But it is expensive because we would have dedicated connection between each and every location. As long as we have, let's say, 3, 4, 5, 10, 20 locations, point to point links are fine. But think of this scenario where, let's say, there are organizations who are having, let's say, 100 offices across the globe. There, it is practically, it's not feasible, right? It's not logical to have, because as we add new office into our network, the number of links would increase exponentially. Earlier, there were three routers, three offices, three point to point links are fine. As I added fourth router, new link added, number 4, number 5, number 6. For three offices, I only needed three lines. However, as soon new office is added, fourth office, now I need total 6 lines. Think of one more office being added into the network. I am setting up my new office, seventh line, 8, 9, 10. Now I need to manage 10 lines. And these are only point to point one line. There is no backup. If I want to have backup lines between them, think of the number of lines that we need to manage. With MPLS providers, what happens? They have their connectivity there across different locations. And in their backbone, they have multiple links, redundant links, maybe via different paths. They would have rerouting in case one link fails in the backbone. Now, if I want to set up a new office, let's say in Chennai, I'll set up a line in Chennai office to Airtel Chennai backbone device. Now my connectivity would be through to any office. I don't need to do anything like I was doing here in terms of more lines. I just need to set up one line and I'm connected to my all rest of the offices. This is the advantage of having the MPLS lines. Anything on this?
No, no, I got it. I got it. Thanks. Thank you so much for the clearing.
Okay, good. So we have private network, we have public network. They are also called hybrid networks. And most of organizations, they do have these two different type of things because even though Airtel would be having their backbone redundant links, right? But still at some point of time, there is possibility that, let's say, there is some problem with this Airtel router itself or this line itself. In that case, the redundancy here won't help until and unless I have another second line here. So instead of having another line to same provider, organizations go for different type of link, let's say internet link to different provider. Internet lines are cheaper and they are anyway backup. They would be used rarely and they are cheaper as well. But the overhead is these IPsec tunnel. So now with SD-WAN, what happens? We have, let's say, I'll talk about two offices for now, two different type of links. One is, let's say, internet like this. Other is, let's say, Airtel MPLS like this. My other site would also is expected to have, let's say, two different links, or even if that site has one link, that is also fine. Delhi, LIC office. This may be, let's say, US location, LIC office. Now, via each type of line, there would be automatic IPsec tunnel established, even if it is MPLS. So, if I assume we have MPLS line as well at the US office, if this is, let's say, Airtel MPLS network, this may be public internet. Even if we have MPLS network, still IPsec tunnel will be there to make it uniform. Although it is not needed to have the IPsec tunnel over the MPLS network, but still this is mandatory as part of the SD-WAN framework, as part of SD-WAN technology. The IPsec tunnel would anyway be there, irrespective of type of WAN line. Anything? In the context of SD-WAN framework, these yellow logical IPsec tunnels, they are called as data plane tunnel. Sometimes they are called BFD tunnel as well. BFD protocol runs on the top of this data plane tunnel. That is why it is called as BFD tunnel as well. And when we will talk about data plane tunnels in detail, I'll explain about BFD as well. What is BFD? Bidirectional forwarding detection. It's a lightweight data plane protocol. And we will talk about more in details. Why BFD? What it does? How it helps? It is very useful protocol in the SD-WAN, and even BFD is also used in the legacy networking as well, in the non SD-WAN environment as well. Okay. Anything so far?
Yes.
Yes, please.
So the BFD tunnel, the BFD tunnel, the protocol runs on top of that. So
Yes.
like the OSPF or your EIGRP runs on top of your tunnel.
Yes.
Okay. Okay.
So similar to that, as BFD runs with OSPF, BGP, or let's say EIGRP, yeah, maybe static
Yeah.
routing. Similarly,
Yes.
in SD-WAN, BFD runs on the top of this data plane tunnel.
Okay. Okay. Thank you.
Okay, good. So keep this picture in your mind. Whenever you think of SD-WAN, right, keep this picture in your mind. There can be same links between, let's say these both links can be MPLS, both links can be internet, or they can be mix of both. Even there can be more links as well. They are not restricted to two WAN lines. There can be 3, 4, 5, any number of lines. It's just that similar type of connectivity should be there between different locations. I'm taking the example of two offices here. There can be, let's say, two more offices. This office may only be connected to MPLS line. This office may only be connected to public internet. Now, the IPsec tunnels, how they would look like from Delhi to this office, because they both are connected to MPLS, from this one, this one. So there should be similar connectivity, similar lines across different offices, different routers. And when they do have similar lines, when the basic fundamental, right? Basics of networking. There would be some IP address here. It's a WAN line. So their WAN IP addresses, as long as they can ping to each other, so they would start setting up IPsec tunnel between them. This is the basic criteria. Anything on this? Okay. Assuming nothing for now. So SD-WAN is the technology of overlay. Let me see why. Oh, okay. So Cisco Catalyst SD-WAN, right, is the technology overlay. So SD-WAN is the overlay technology because there would be logical IPsec tunnels on the top of physical lines. So that is why it is called the overlay technology. That everything that will function would be part of overlay. Why? What I mean when I say that, taking the comparison between the, let's say, if this is the first one, maybe SD-WAN setup, or the two routers who are in the SD-WAN mode, they are part of SD-WAN technology, and this is, let's say, non-SD-WAN or legacy network. So if this may be some provider, maybe internet, maybe public network or private network. So with legacy networking, there would be manual IPsec tunnel. If we configure optional, with SD-WAN, it is mandatory. Automatic IPsec tunnel would be there. So if I have some user who is sitting here and they want to communicate to, let's say, server on the right hand side, there would be cable connected via switches to the router. These are the routers, assuming. And then similarly, one PC connected here, just to show you the comparison, how it goes when networks are part of SD-WAN or when they are not. Now, when this user on the left hand side, if the user wants to access the server on the right hand side, their request will go to this router, to this network, and like this. Anybody who is sitting here, 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 or maybe here, they can sniff into our data because our data would be naked. It's not encrypted. It's not secured. Now, talking about SD-WAN, be it public, be it private network, whenever this user is trying to send the data, this data would enter into this IPsec tunnel. The data would be encrypted. And this data would, when it would land here, then it would be unencrypted. And then naked, it will travel to the server on the right hand side. Across this path, nobody can see into our data. This is where security with SD-WAN is there. So SD-WAN is the technology of overlay technology and secured natively. We are clear now why we say SD-WAN is secure.
Oh, I have one doubt in this.
Mhm,
So, suppose that you say in the term of SD-WAN, we are creating the IPsec tunnel in between
mhm,
the two peers.
mhm.
Okay. So here we are using SD-WAN technology in between of them. Suppose that we are not using the SD-WAN technology, we are using both level have any firewall level. We can
Okay.
create the IPsec tunnel. From
Yes,
there also we can just we can peer can negotiate the data also. So
absolutely.
here why the only SD-WAN? Like you said in a previous
Mhm.
your explanation, you said automatic tunnel is
Yes,
creating in the SD-WAN, which
yes,
is very helpful to the like suppose we have a
correct,
two or three ISP links, cheaper
correct.
ISP links. So suppose that we have created one IPsec tunnel to that branch. Suppose that
Okay,
one or two link will be down, then another third link will be like
right,
communicate with that same IPsec tunnel.
correct. Yes,
So in this, like I'm saying, we can create without SD-WAN also. Now, like we if suppose both side have a route this firewall also, then we can
absolutely. You can.
create it.
The difference is in terms of manual and automatic. With firewall, there would be manual way of configuring the tunnel, right? People need to be aware about IPsec configuration, IPsec parameters, phase one, phase two, right? What are the encryption
Right,
algorithms? What are the
right.
integrity algorithm? What is free shared key? With SD-WAN, you don't need to be aware of these things. We even don't notice that which protocol is running, what encryption algorithm is running. We don't need to worry about.
But then the end of that, it is running behind of that, right? It's using the
Yes,
algorithm to encrypt to decrypt the packet.
absolutely.
So
Yes, but
is it
they are using same
possible?
algorithms on all the
Is
routers by default, but we can customize. Yes, please go ahead.
okay. So is it possible? Can you elaborate more like how it is automatically creating in the SD-WAN?
So
Like
we'll talk
if
about
you
in more
okay,
details. Today,
okay,
I'll be outlining on high level what are the advantages. This is one of the advantage of SD-WAN. There are several others. We haven't yet talked about that. And we'll be talking about each one of them in details. There would be full day session, let's say full 1.5, 2 hours. We'll be talking about data plane IPsec tunnel only, the in depth. Yeah. Okay.
okay, okay, no
So
problem.
yeah, yeah. Okay, good. So overlay technology and secure, thereby saving us cost in terms of using internet lines majorly. So you might have heard, right, everyone, that people say that MPLS is being phased out. MPLS would not be in use anymore, but that is not the case. The reason, two different types of links. MPLS would still be used, public internet would still be used. It's just that MPLS links earlier, they were independently working. The data was traveling inside the IPsec path, sorry, over the MPLS path inherently, right? Now, same path, same set of routers would still be there. However, the IPsec tunnel would be established on the top of this even MPLS path. Even though it's a secure path, we don't usually configure the IPsec tunnel on the top of the MPLS path, but still with SD-WAN, it is mandatory, and this automatic IPsec tunnel would be established. Yeah. So MPLS is still needed. It would still be in use. The only difference is now it would be underlay. It would become underlay, which is helping to set up the overlay IPsec tunnel, and data would be traveling inside this IPsec tunnel. It would be now tunneled. It's not open traffic anymore. So with why we are saving cost, we are using less of the MPLS lines. Why less of MPLS lines? Because we now have automatic IPsec tunnel over the internet lines. So we don't need to worry about the manual IPsec tunnels. Since there are automatic IPsec tunnels, so we can use internet lines. And as I told you in the beginning, the key point that internet performance is now improving. So most of the organizations, they have started using more of the internet lines, less of the MPLS lines. And this is the reason the SD-WAN was invented, to make use of, to take the advantage of the internet lines by saving money, by saving cost, by using more of the internet lines. We can have, we can save cost, and on the top of that, we have automatic IPsec tunnel. So it's giving us security as well, which was the major flaw with the public internet before. Okay. So yes.
So okay, so the SD-WAN sits on top of the MPLS,
Yes.
and MPLS sits on top of the regular routing infrastructure.
Absolutely.
Okay,
Absolutely.
okay, okay, all right.
Now the difference, right? Again, if we talk about legacy networking, if let's say there are, I have 4 different VLANs with these subnets, right? Earlier, these 4 VLANs, they were advertised as it is to this router. From there it travels down, and this Airtel MPLS or any MPLS provider, their edge routers, there we can see all these 4 subnets, right? And along with these 4 subnets, there would be some connected subnet here, /30, let's say point to point link. So at this provider edge router, there would be total 5 subnets. With me? So there would be total 5 subnets seen there. With SD-WAN, what happens now? This edge router would only be seeing this subnet 50/50/30. If I run show IP routing command on this edge router, I would only see this subnet. These 4 subnets 10, 20, 30/24, they won't be seen here. These subnets would still be there, but they would be part of encrypted tunnel. So if we run that command here, show IP route, we won't see these subnets. They would be part of encrypted data now. They won't be advertised naked as they were being advertised with legacy networking. You see the difference? And we'll talk about more in details how these subnets are advertised, right? In usual this networking terms, they are called as LAN subnets because they are representing the LAN infrastructure, different servers, applications, and this 50/50 is usually called WAN subnet. So WAN subnets would be advertised to providers. They would be carried. So provider would still see my WAN subnet. However, my LAN subnets would be hidden now. They would be encrypted. They would be part of encrypted secure tunnel to SD-WAN controller. So one element that we need to set up when we are moving from legacy to SD-WAN, we need to set up SD-WAN controller. It's a combination of at least three machines, three virtual machines. Before moving any of my device into the SD-WAN mode, I need to first set up SD-WAN controller. So when we are talking about transforming our legacy network into the SD-WAN network, the first step would be is to set up three virtual machines which are called as SD-WAN controller conclusively. However, each one of them, they have their own role, their own name. Like one of them is called as VBond, second one is called as VSmart, third one is called as VMatch. So these are the names of these three virtual machines. There is no such thing as, let's say, vManage. There is no such hardware that can be purchased. It's virtual machine on any platform, on any cloud, let's say AWS, Google, on our, let's say, private cloud. We can even set up these controllers on premises. I just need to have one x86 8086 microprocessor controller server on which we can create different virtual machines, and to those virtual machines we can delegate this role by activating their respective image. Anything? Okay. So this is the very first step to set up these three different controllers, because these routers, when they are part of SD-WAN mode, then they are part of SD-WAN technology. They are kind of dumb devices now. They all need assistance from these controllers to communicate further. Even these subnets, they would be sent by each device to this controller, let's say VSmart, and between each controllers themselves and between routers and controllers, there would be another set of secure tunnels that would be established. So if I move to, let's say, different main screen, so
Sir, one thing you just mentioned, we manage and
mhm,
we smart
mhm,
and we bond. That
mhm.
controller only should be in the like head office, or like head office branch also everywhere is there. This controller
It can be anywhere. It's just that the IP
anywhere.
reachability should be there. Yes.
No, basically when you will design for the SD-WAN, just
Mhm,
like example the MPLS cloud or something the branch
mhm.
also there. In head office like one of the cloud from there, all the branches to connect to the head office. And that is like whatever the ISP and routing protocol is there in the cloud. Means whatever the connection is there from branch to the head office. In that scenario, the SD-WAN is any like one
Okay.
centralized
So,
there. Yeah.
so if I take the example here, two different examples where and how these controllers can be set up. Three different virtual machines, and on the left hand side is the example when we have SD-WAN controller on cloud, or let's say known DC or known HQ site. It can be on cloud or on premises. And when it is on premises, it is not any of the data center or HQ site. So still, when these are three different machines, we still need some sort of device which would be providing IP reachability. So this is known as the WAN device. It can be any vendor. It can be a Juniper device, Juniper layer 3 device, or it can be HP. It's just that it should be a layer 3 device. It should understand routing. That's it. Then there should be some provider who would be providing the connectivity. It can be one provider, it can be one type of connection, or it can be multiple connections. Three different routers in SD-WAN mode. So this is SD-WAN. This is also SD-WAN. This is also SD-WAN device. It's a non-SD-WAN device. The role of this non-SD-WAN device is just to provide the IP connectivity so that the IP address here can communicate to the IP addresses configured on these three controllers. There are three virtual machines, so they would be having some IP address there. The role of this router, this device, is just to provide the IP reachability between these set of IP addresses. And then these three controller machines, they would be helping each of the edge routers, each of the routers to let them know their IP addresses. How this my router 1 would set up the IPsec tunnel to router 2. I said automatic IPsec tunnel, but how would they get to know their IP addresses? Because they would be ultimate endpoints of the IPsec tunnel. So before these routers, router 1 and 2, set up their IPsec tunnel, they first need to set up their SSL tunnel to these controllers. This is basic prerequisites, and it is also automatic. All these tunnels which we are talking about, they are all automatic. We don't need to do anything. We just need to set up few basic lines of configurations, and that would let them do all this magic, right? So this tunnel is TLS based, certificate based, SSL secured tunnel between controller to edge router or controller to SD-WAN device. So edge router, or let me call it CH, Cisco router in SD-WAN mode, to controllers. It would be TLS or DTLS tunnel. TLS is transport layer security, DTLS is UDP based, and TLS is TCP based. This is the only difference. And TLS means the certificate secure tunnel. So when these tunnels would be set up between the CH to controller, then it would be certificate secured DTLS or TLS tunnel. However, CH to CH would be IPsec tunnel. The role of these TLS or DTLS tunnels between CH to controllers is to let other all devices talk to each other. So when CH to controller, this is the first thing that would happen between CH to controller. When this tunnel is established, each router is expected to do this job by default, again automatic. When this happens, this device would know now the IP address of all the devices. What it will do, it will exchange the IP addresses. It acts as route reflector. Whatever it receives, it reflects to other all devices. In this way, these routers would get to know about their IP addresses and their IPsec parameters. Using that information, these routers would establish IPsec tunnel between them. Is it? Does it make sense? We were talking about the difference, right, when we are having controllers on data center, right? Now, assuming on the right hand side, what we have SD-WAN controller on the data center or on HQ. Still, I need some layer 3 device who can give me the IP reachability. Again, it can be any vendor, any make layer 3 device. It would be again be known as SD-WAN. On the data center, we are expecting more infrastructure, right? In terms of servers, let's say if these are these servers which are hosted on the data center. So these servers are expected to be accessed via other sites. So I would need one SD-WAN device as well. This SD-WAN device would be connected to different servers via switches, firewalls, etc., which would provide the connectivity to the servers as well as to the controllers. Now, the connection between these routers, this is the IPsec tunnel between SD-WAN devices. However, these SD-WAN devices, even this SD-WAN device, to get connected to this router, to know the IP address of the remote device, it would need still to go to the controllers, because this device would be sharing its information to controller. Even though this SD-WAN device, this known SD-WAN device, they are sitting part of same infrastructure, still this SD-WAN device needs to go to its controller. Is this clear now? Anything? So even if, right, I know there may be a situation, right, where we are not, we cannot say that we really understand, and we cannot really imagine that if we really could not clearly understand, right? So it happens when we are learning something new, right? So don't worry, we'll be talking about these things in much more details. So today, my perspective is to just to give you the high level overview, right? That how things go. So don't worry, we'll be talking about all these things in much more details. So this is confusing when we are setting up controller on the data center HQ. So you can ignore for this here for now. Just try to understand from this perspective, because this on the right hand side, I haven't seen, right? In almost all topologies, all networks, we have connectivity like this on the left hand side. Okay. Then C edge I talked about, and there is a V edge. These are the, when we say edge, they are the routers where the LAN infrastructure, switches, servers, printers, users would be connected. So C edges are the Cisco router in SD-WAN mode versus Cisco router in non SD-WAN mode. A Cisco router, or to be more specific, Cisco iOS XE device. Because when we say Cisco iOS XE device, it can be ISR 4000, ISR 1000, or it can be Cisco Catalyst 8000 devices. So these devices can only run SD-WAN. Any other platform, let's say Cisco CSR devices, the backbone devices, they are not capable to run the SD-WAN. They are not capable to set up automatic IPsec tunnels. In more specific terms, these routers can be in SD-WAN mode or in non-SD-WAN mode. When a router is in non-SD-WAN mode, it cannot do the intelligent functionalities of the SD-WAN like automatic IPsec tunnel. It won't be able to understand what is that. Two different worlds. Then VH is the Viptela device, which is always SD-WAN device. It cannot non-SD-WAN. So Viptela was the company who invented, who developed what is called as Cisco SD-WAN today. So when Viptela, around 2012-13, when they were working on SD-WAN, at that moment, no Cisco router supported SD-WAN. Only Viptela devices. Different company, everything different. Then later, when this technology picked up, right, then Cisco purchased or overtook this company. And then started merging SD-WAN into Cisco iOS XE images. Slowly and gradually, then V-edges are now being phased out. No more new manufacturing, no more OS support, no bug fix, no RMA. If there is something, Cisco strictly recommends to move to the Cisco routers. So V-edges, they are, as I told you, different Viptela hardware. Like with Cisco, we have different models. Let's say Cisco 4300, 4400 devices, right? Let's say 4451. Similarly, there are different Viptela, different hardware models. Like they are called as VH100, VH1000, 2000, according to their different capabilities in terms of, let's say, performance, etc. Different models, similar to Cisco. Anything on this? So this Cisco router in non-SD-WAN mode is a traditional or legacy router who understands normal IP routing, everything that we do, ping, trace, etc. And a Cisco router in SD-WAN mode, it is more of intelligent device, we can say. It now understands, establishes automatic IPsec tunnel. It understands TLS or DTLS connections and many more things which we'll talk about later. So when when let's say Cisco router is in legacy or non-SD-WAN mode, right? Then when we run this command, show version, pipe include, let's say if I run this say mode, if it says autonomous, then that means it's a legacy router. When it says controller mode, then it's part of SD-WAN. It's SD-WAN device then. There is command controller mode enable or disable. Disable, controller mode disable would run when device is in SD-WAN mode. This command of course will run when device is in legacy mode. Each time when we switch the mode of the Cisco IOS XE router from controller mode enable to disable, or let's say disable to enable, the device would reboot and the configuration would be erased. It would be set to the factory default configuration every time we make a switch. Okay. Anything? Okay. I'm done for today. So I'll stop screen sharing. Okay. So there is one message from Amit. Nokia NOS is the data center solution. Okay, that may be true because I don't quite know about the Nokia NOS. It's just my high level understanding that Nokia NOS is the one of the flavor of the SD-WAN. Okay. Okay. So we'll close this session for today. Open for any doubts, questions. If you want, you can put up your queries on chat as well.
Okay, sir, one question. This
Yes.
SD-WAN like support like a small organization. Someone say like it will not support like example, there is one site there like around like 1 or 200 user is there,
Mm-hmm.
and another site also like more than like 1500 user. So
Mm-hmm.
it is better to don't change to the SD-WAN. MPLS is good, but if it's not support for this like we have just tell me it is correct or
So I don't think, right, as much I know and as much I have seen, right, I have seen SD-WAN network with 2000 devices, 2000 routers, and where there most of the sites are having, let's say, more than 200, 300 users. So SD-WAN, specifically Cisco SD-WAN, can be used for any, let's say, scale. It can be used for small networks. Let's say I have seen a network. We did a project where we moved the these were the seven US hospitals chain. There were seven hospitals which were earlier working on, let's say, Palo Alto, and we transformed their network to Cisco SD-WAN. And I have seen a network with 2000 edges, 2000 Cisco routers. So Cisco SD-WAN specifically can be used for any scale, let's say for smaller networks, medium networks, or even for the larger networks.
okay. But
And
some of the area, sir, some of the area like
uh-huh.
they are replacing the router to change to like Fortinet firewall on the SD-WAN. That is a
um,
concept is same, but the devices change.
so
Like
either
for
it can be all Cisco SD-WAN or it can be all Fortinet SD-WAN. It cannot be mix of both.
no, only for the FortiGate the changing.
Yes, that is
Before there
possible.
is a
Yes.
yeah possible. Before there is MPLS router also there. They
Uh-huh.
replace to this replace the router, and the instead of router they put the FortiGate firewall and to
Quite
cancel the
possible.
MPLS link. Yeah.
Yes.
Mm.
Yeah, even I had worked on a project where, yes, we did similar thing. We phased out the Cisco routers and then set up the Fortinet firewalls using as
Yeah.
SD-WAN device. Yes, because security is there with the Fortinet natively inbuilt, right? Security is not only in terms of IPsec tunnels. There are other aspects of the that we do with the next generation firewalls, right? IPS, IDS, URL filtering, DNS filtering, etc.
Yeah, a lot of security also there. And
Yes,
again thing and they work like Intel I think the routing like a BJP they're using for the specific like
yes,
yes. Yeah.
yes, you're right. With Fortinet, BGP is in use for the WAN routing, right? But What Fortinet SD-WAN is, right? That is only, you can say, 30-40% of what Cisco SD-WAN can do. Although Fortinet, they have inbuilt the SD-WAN, but still Cisco can still only support the larger networks in term where there is complexity or where there are customized networks.
Okay. And in this scenario, sir, one I just saw this one also. One side, they are just like three side also there. He mentioned this
Mhm.
one head office, one side like that the different three side also there. They can create the like tunnels for the three side, and they can the like load balancing also there. Both are
Yes,
like both are
yes,
the firewall is active and the load balancing also there. The traffic is
yes.
going by both way.
So when we have, let's say, two firewalls, right, it really depends if they are uh, working as active or if they are working as active backup, right? So yes, so there are certain advantages. We admit that there are certain advantages with the other vendors as well, which Cisco may not have. Cisco is not, let's say, Cisco may not be as security leader as Fortinet is, right? So it really depends if we really need all those security features. And with Fortinet, we can say we'll get more of the security, but less of the SD-WAN or less of the complex SD-WAN things. With Cisco, we'll get more of the complex SD-WAN management, but complex network management, but less of the security. Yeah,
Sir, SD-WAN is different in in Fortinet versus Cisco. In Cisco, we divide control plane and data plane. In
yes,
Fortinet, they just aggregate different links. I
yes,
think
correct,
in SD-WAN.
correct. So that's why I'm saying, right, Fortinet SD-WAN is only what only 30-40% of what Cisco SD-WAN is.
Fortinet just we aggregate different links like
Yes,
MPLS, internet,
that is the
satellite, right?
only advantage of SD-WAN. Let's say if we chart down 10 or 15 things what are new with the Cisco SD-WAN compared to the legacy networking, and then when we compare it to Fortinet, we only have one thing, that what you correctly said, aggregating multiple links. Yes,
And also in Cisco SD-WAN, we can buy simple routers, means without a intelligent on branch
absolutely,
and one intelligent router in headquarters.
absolutely.
So we
Yes,
can save cost.
that's right. That's right. Yes, correct.
Okay.
Okay,
So
nice.
means we can use MPLS with SD-WAN and we can buy
Absolutely.
cheap routers on branch
Yes,
sites and expensive router on headquarters
that's correct.
to save
Yes,
money.
yes. That is the ultimate agenda for the SD-WAN. Yes. Again, it
Okay.
indirectly contributes to saving cost because we can manage with the
Yeah.
lower end branch routers. We don't need to buy high CPU routers.
So so in branch routers, these are routers are simple. They don't have control plane capacity.
So they still have control plane capacity in terms of, let's say, CPU, but when we say when the routers are in the known SD-WAN or legacy mode, they are doing 100% of the control plane thing. But when they are in the Cisco SD-WAN mode, right, then they are doing only 10% of the control plane job. So 90% of the control plane job is extracted. That role is given to VSmart.
It is just like a wireless controller.
Kind of.
Means we have one.
Yes, kind of. The intelligence or everything management is attributed to the like WLCs, right? Similar to that here also. But here in SD-WAN, there are three virtual machines who are acting as one machine. Like, let's say when we have wireless LAN controller, WLC, that is one machine. In Cisco SD-WAN, we have three machines which would be acting as WLC.
Okay.
Okay. Anything else, anybody? Okay. Assuming nothing, but I hope there would be much more queries, many interesting things to talk about. So we'll continue tomorrow then. Thank you all. Thanks. Yeah. Have a good day. Thanks. Bye
Okay.
bye. We'll be closing
Yeah,
this session for
thanks.
today.
Okay.
Thank
Thank you.
you.
Thank you.